I'm going to check in with Dave Hyland. I know our next presenter is here. Dave, if you're ready, I think we can start a bit early.
You
If
ready
not,
for me?
You there, Dave?
I am. Can you hear me all right?
I can. Let's get you dialed in here.
Okay.
Hey, Dave. I see you. Let's get a little intro for our friend Dave here. So our next presentation is going to be from Dave Hyland, professor from Xavier University. Dave's going to be discussing the relationship between batting metrics and runs scored. So, Dr. Hyland, veteran presenter at the Analytics Conference, welcome back. Take it away. You've got an hour and 10 minutes now.
Okay. Okay. Thanks, Scott. Having done this a few times in the past, I know that there are a lot of different users out there. So I tried to put a presentation together where we're going to talk about some main concepts. We're going to do some basic R programming, and then if you're already a Power R programmer, Scott's going to post my R code, and I've got a lot of hidden code that does some of the graphs a lot nicer. So hopefully there's something in it for you. So I'm going to switch over. Just the presentation is called The Relationship Between Batting Metrics and Runs Scored. And essentially what we're gonna do here is look at some of the traditional statistics, that have been around baseball for a long time, and look at the validity of them, but eventually build toward and develop and talk about WOBA, which I saw a real interesting fan graph that describes WOBA as kind of a gateway statistic. Like think drug gateway. It kind of gets you involved in the more advanced statistical concepts and things we're doing. So one of the things I put in this PowerPoint is I'm going to do some introduction here, give a little background. But if you're feeling brave and you want to download R and R Studio and try to work along, just search download R, download and install that, and then download and install R Studio. We're going to be using, I know you had a discussion of the Laman database, which I just found out today is being hosted by SABR now, I guess, which is really cool. What we're going to use is there's an R package that lets you access all the Laman data without having to read in files and so on. So it's really convenient. If you can you can do some basic R programming. It's a really great way to use the Laman data. So I always think I had a professor a long time ago that said it. When you take a course from somebody, you're trying to learn something from somebody, it's important to know something about them, right? So I'm a finance professor. I don't come to this as a trained statistician or a data analytics person. I'm a finance professor, and so if you think about finance as a profession, we're looking for value in things. Where are things that are undervalued and so on. And so I think books like the movie and the book Moneyball really related to me. I teach a course at Xavier called Sabermetrics, where we use all baseball data, and it's a statistics course. A lot of fun. I'm also director of analytics for the baseball team. I've got a picture of our guys down here at the Big East. I just started volunteering, doing some stuff with them. And we've started this program called XBAT, Xavier Baseball Analytics Team. And we get students that help the coaches get prepared for do advanced scouting, get data together for them before games, and then do post-game reporting. So I know a lot of programs. If you're interested, a lot of baseball programs would love to have the help. My suggestion would be, though, to do something first. Go take some data you find. I think the last one on Baseball Reference. There's a lot of college baseball data on Baseball Reference. Take that about your team, do some kind of report, do some kind of graph, take it to the coaches. I think what happens a lot is students say, hey, I want to help. Well, really, Scott, do I need to do something for full screen?
Yeah, we're working on it. We'll figure it out for you.
Okay. Just keep going.
Yep.
Cool. And then finally, last thing, I'm part of a little group that owns a minor league baseball team, independent team, the Florence Y'alls, and our little group just bought the Windy City Thunderbolts. And I know students are looking for opportunities. Sometimes those minor league indie ball teams, college teams, those can be great places to get started. A lot of times there's not much pay involved, but it gets you involved in projects, it gets you involved doing things. So think about volunteering, thinking about some of that. All right, so here's our agenda. What we're going to do is take the we're going to use the Llama database package in R, and we're going to examine run scoring with traditional baseball metrics. And we're going to look at some of those, and eventually we're going to talk about how to create linear weights in WOBA and how we tend to think about the game now. All right, so here's the little histogram of runs scored historically, and let's jump over to R. Let's jump over to R. All right, so here's R. If you haven't started before, we're gonna start out building that graph in R with the Llama database, and then we're going to talk about runs. So if you've never used R before, we've got you open it up, you've got 4 windows. This is where you write your script or your program. The upper right is where all your objects are, like your data sets, values you create, and so on. Bottom left, the console. This is where your work prints out. And then bottom right's kind of a miscellaneous area where we might have graphs, print, things like that. So we're going to use 3 packages today. We're going to use the Llama database, which we talked about, and it's capital LAHMAN. And I need to make that install packages. To run a command, we have our cursor on the line, hit Control Enter, and we look down below, and the Llama data package is successfully installed. We're also going to use tidyverse. This has a lot of the statistical data wrangling type things we're going to use. And then finally, we're going to use ggRepel. And ggRepel just lets us make some cool looking graphs. So I need to put install packages, and there we go. So we've got our 3 packages loaded now, or installed. Now I have to, every time I go in, I have to use the library command. I'm going to load the Llama package into the library, the tidyverse, and finally ggRepel. So hit Control Enter on each of those. I got them to run down in the bottom. Next time I come into R, I'm not going to have to reinstall the packages. So I can just do Control-Shift-C. That'll put a pound sign in front of each line, and that'll turn it into a comment. So I don't need to install the packages every time. They're going to be there. All right. So real quick, before I go much further, can I get a comment? Is the font size big enough for you to read on the computer? I do need to make the window size a little bigger. Bigger, okay. So we'll go view and make it, how about that? A little better? Good enough? Good, good, good. Hey, and I forgot to mention, I did not realize that Xavier basketball was going to be played during this presentation in the Big East. So if you want to chime in with scores in the text, there'll be no complaints for me. All right, so we've installed our packages, the Laman database, tidyverse, and ggRepel. So let's get started. One of the things we can use is the help command. We're going to use this Laman package, so we'll use the help command on Laman, hit Control Enter, and it'll just describe over here what some of the information is. And if you saw the earlier presentation, you'll recognize some of these tables like teams, pitching, batting, people, and so on. Thank you, 1916, that sounds good. So help command, don't use that much. But now we can go ahead and get started. What I'm going to do is I'm going to talk about run scoring with the teams data frame. Okay, so in Laman, we opened up, I'm not sure exactly how you did this morning, but maybe use SQL to load in teams. With the Laman database in R, all I have to do, I'm going to create an object called teams, which in this case is a data frame. I'm going to use so this little looks like an arrow here, the less than and minus sign. That's basically an R saying everything to the right of this, we want to put it into an object called teams. So the Laman package has a table called teams. If I'm just using lowercase teams to differentiate it from the package team. So I'm going to create if I hit Control Enter here, I'm going to create a new object up in my global environment called teams. Let's open that up and we'll see, just like you saw before, we've got every team that's played in the major leagues from 1871 and so on. It's got their wins, losses, and so on. So we got a lot of good data on all the teams. Likewise, if I wanted to do look at individual batters, we could load in the batting table. So we've got the batting table. I can open that up and I can see, look, we got David Aardsma, played from 2004 to 2015. There's Henry Aaron, 1954, and so on. So we've got each player that's played, each player that has played in the MLB. And I got a question. Yes, Jacob, to answer your question, 48 variables. We've got 48 different stats on each player for the teams. We've got 22 statistics or season statistics for all of the individual players. Right? Something exciting must have just happened in the Xavier game because my wife just screamed. She's also a professor at Xavier, so we're big fans. All right, so we've loaded in teams, we've loaded in batting. Let's look at run scoring. And one of the things that I really like about R, the main thing I like about R is it's the package I know how to use and I'm good at it. And you get advice all the time. What should you learn? Should you learn R? Should you learn Python? Should you learn SQL? I mean, all of them are good, right? I do, everything in my world looks like an R problem. Somebody that's good in SQL, everything in their world looks like an SQL problem, right? I think it's worthwhile just to get good at one of them, right? That's a great place to start. Students ask that question all the time. So one of the things I love about R is graphing capability. So let's do the graphing capability in tidyverse is called ggplot. So ggplot is a package in a sub package within tidyverse. So it looks clunky when I first start. So I'm going to feed it the data frame. The data set I want to use is teams, and the aesthetic AES. The aesthetic, that's the thing that I want to plot. So in this case, the aesthetic I want to plot is just runs, and I'm going for ggplot. The beauty is we can just keep adding layers with the plus sign. So I'm going to do ggplot. I'm saying the data I want to use is teams. The aesthetic I want to plot is R. The next line I'm going to say histogram. And I can get more detail on that. But basically I just give this basic command is going to give me a histogram of runs, right? So we want to understand batting. So obviously it's important to understand run scoring first, right? So if I notice, it looks like it's sort of a normal description, but I've got a team that maybe scored, just a couple runs here down. Well, a lot of this data is pre-1900. So let's narrow our data frame down. Let's say teams full season. So we'll create a new data frame called teams full. And what I'm going to do is I'm going to use teams. Control-Shift-M gives me this percent greater than percent. So Control-Shift-M. I'm going to give myself a comment. Control-Shift-M gives me the pipe operator. And the pipe operator is like a then word. So start with teams, start with the data frame teams, and then I want to filter for year ID greater than 1961, and let's say games greater than 157. And I pick 157 for games because that'll eliminate years like the COVID year 2020. It'll eliminate some of the strike years, but it will still keep in some of the teams that had a few rain delays and didn't get all 162 of their games in. So let's run that command. So any line in it, I hit Control Enter, and I've got a new data frame called Teams Full, which is about half of the data in Teams. I go from 3,000 observations to 1,500. And let's create a histogram. Let's create a histogram just with that. So I'm just basically going to use the same code from above. ggplot data equals teams. The aesthetic is R. And we're going to create a histogram. All right. And what happened is I just used the old teams. I forgot to use the teams full. And now I get a histogram that makes a lot more sense. No teams. If I zoom in my graph, there aren't any teams that are getting, 1 or 2 runs. But there is a team out here getting over 1,000. And I know we're all curious about that. So before we, in response to Jordan's question, stat bin, if I get into more details, I can feed the histogram, how wide I want the bins to be, or what's a minimum number. So the beautiful thing about ggplot, I can get very, very detailed and really control exactly how my graph's going to do. For today, I'm just going to use really basic commands. If you look at the R code, my R code file, I've got some more detail that shows some examples of how to make these more controlled and prettier. All right, so here's our curiosity question. You know, who scored over 1,000? And what we're going to do is we're going to take our teams full. We're going to take our teams full. And this time, I'm not going to use my left arrow. I'm not going to use the arrow pointing into an object. I'm just going to have it display in the console. So I'm going to start with teams full, and I'm going to filter for runs greater than. Let's do that. Let's do runs greater than or equal to 1,000. And just to keep all 48 variables from printing out, let's select year ID. And I know the data frame pretty well. You might need to, you look up, oh, what are the variable names? Oh, it's year, capital ID, it's T, capital ID, and so on. That's just a function of, getting experience with the data you're working at. All right, so let's run that. So I've got a pipe, I've got teams full, I hit Control-Shift-Enter. I filtered for runs greater than or equal to 1,000, and I selected year, team, and runs. Let's hit Control-Enter, and we find out that the team that scored more than 1,000 down here in the bottom in my console, 1999 Cleveland, scored 1,009 runs. So that must have been quite a year. That must have been quite a year if you love offense and you're an Indians fan, right? All right. So let's do this. Let's flip back. Let's flip back to the presentation for a minute. All right, so just to make it a little fancier, you see there's our histogram. We tighten up the bins a little bit. We put an average line on it there. So an average team scores 715.62 runs in a season for teams that played at least 157 games, right? So that's great, but let's see how it equates to. Let's see how it equates. How does scoring runs affect winning, right? And we know there's a positive relationship here, but let's go ahead. I think it's worth going through some of these basic things to get ourselves going. So let's start with teams full. And I need to create some new variables. So I'm going to overwrite teams full with teams full, Control-Shift-M to create my pipe operator. I want to create new variables. The mutate function allows me to create the mutate function allows me to create, oops. And I got away from there we go. The mutate function, M-U-T-A-T-E, allows me to create new variables. Sorry about that. There we go. Mutate function allows me to create new variables. And the variables I want to create are winning percentage. So we'll just say winning percentage equals wins divided by wins plus losses. We'll put a comma there. So notice these two parens are going to close off anything that I want to create in terms of new variables. So I'm going to create new variables. I'm also going to create run differential. runs minus runs against, right? Because we know that run differential is actually going to explain winning better than runs, but let's see how much of winning percentage gets explained by runs. And then one other thing I'm going to do is I'm going to create a variable called team year. And with team year, I'm just going to paste together the team ID and the year ID and separate those with nothing. So double quotes. I'm going to separate. So it's going to look like CLE 1999, right? So those are my new variables. So let's run that, and it doesn't like my W. Does anyone see what's wrong with that code? Lowercase. Right here, right? There we go. Good catch. All right, so team's full. We were created three new variables. So if we were paying attention, we had 48 variables before. Now we've got 51. So we pasted team ID, year ID, separated. So let's create a graph. Let's create a scatter graph where our data is teams full. And the aesthetic, we want to plot x equals, we'll start with runs, x equals runs, and y equals winning percentage. We'll add on to that, and instead of histogram, we're going to point will give us a scatter graph. All right, so let's run that. And here's my relationship between run scoring and winning percentage, right? So obviously it looks like a pretty positive relation, but still a lot of noise in there. Let's go ahead and put a smoothing line in there. All right, so we see the blue line going through, and it looks like a pretty positive. The more runs you score, the higher your winning percentage is. Yeah, we kind of know that. Then one more thing we want to do in this graph, let's put some labels on it. So we'll use this text repel. And with text repel, we're just adding a layer, and we're saying the data is teams full. The aesthetic is x equals r, y equals WP, and label equals that variable I created, team year. So it takes a minute to grind away. And here we go. So we get some of the big outliers, right? Seattle won, scored a lot of runs, but did way better than just run scoring. What happened? So we've got to figure that Seattle 2001 team, they also had some really good pitching as well. The Yankees here in 98, good pitching. These teams down here, probably not so great pitching, right? So let's switch back to our slideshow for a minute. There we go. So we did run scoring. The amount of runs you score, yeah, it matters, but our R squared really only explains about 28% of winning. If we take it further, if we look at run differential means a lot much more, right? When we look at run differential, we get an R squared. Really, the model explains 88% of winning percentage. We look at the actual equation, and we can look at this a lot of different ways. But a lot of different ways we look at run scoring and run prevention. Each additional 10 runs you score gives you an extra win. And why isn't it just one? Well, maybe you get that one more run in a situation where you were down 5 or you were up 7, or so on average, another 10 runs get you a different win. So when we start to think about things like war, where we're trying to figure out how much value is created by a player, we're looking at things that score runs. And if I find activity that scores 10 runs, that should give us another win, right? So we think about kind of the last step of war. We're going to be thinking about, okay, how many runs did this player's activity add? If I divide that number by 10, that's going to give us a good sense of how many wins they helped the team with. Like above average or above replacement. That gets into different concepts, right? All right, so let's look at some of the traditional metrics, right? So the traditional metrics, we're used to are batting average, hits divided by at bats, on base percentage, right? So back in the early days when the game was created and they were still, trying to decide what was valuable, walks were really, really more of accidents. So finally, like, we're giving up on this guy, we're letting him take first, but the activities in hitting and so on. So a lot of these, at least the batting average and slugging percentage can be dated back to at least as far as 1869, when Henry Chadwick was, kind of reporting on the game, started presenting baseball statistics, rich tradition from cricket. So at first, kind of the batting average and slugging percentage were kind of two competing ideas. The slugging percentage, the idea was, well, batting average misses out on that a double's worth more than a single, and a triple's worth more than a double, and a home run's worth more than a triple. So we got to remember, this is back in 1869. Not a lot of computers. Takes a lot of time to put this kind of stuff together. And, we're just using rough measures for doubles, triples, home runs. To ruin the plot, I always tell business students, we're not in the business of doing murder mysteries, right? Essentially, what WOBA, where we're headed towards, WOBA is a statistic where we try to figure out how much a single's worth, how much a double's worth, how much a triple's worth, and how much a home run's worth. And of course, we can throw in stolen bases and caught stealing as well. But ultimately, at the end of this presentation, we're going to try to take this crude statistic from 1869 and bring it up to a modern era with computers and so on. And we'll see it wasn't that bad a concept, right? All right, so what we want to do is we want to take these traditional metrics, and let's go over to R for a minute, and let's just create some graphs where we predict we predict run scoring. We want to predict, so in R, let's predict or explain, better word is explain. Let's explain run scoring with traditional batting metrics. And let's start with some housekeeping. when we work with Lyman data, a lot of the variables can be NA. Like there are periods where we didn't keep track of wild pitches or sac flies, so we get a lot of NAs. And kind of the approach most of us take with that kind of data is, let's treat NAs as zeros. That can be really dangerous in some other types of coding or statistical work, but for the most part, it seems okay here. So we're gonna treat NAs as zeros. So let's do this. We're going to start with our data frame, team's full, and we're going to overwrite it with our left pointing arrow. We're going to start with team's full, and what we're going to do is we're going to mutate across. And you're saying, how does he remember this? I don't remember this. These kind of commands are really hard for me to remember, right? They're good. I find them in old code where I'm pulling it up, but I've really found that ChatGPT and some of the other AI sources they're really good for programming. I just say I've got a data frame and I want to turn all of the NAs into zeros. Can you give me some code? That is I think where AI is really great, right? I know what it is that I want to do, and I just ask it to write the code. Probably saves me a lot of time. I don't have to remember that this period was here and this is a tilde and all that. So to me, that's the place to, it looks like I've got something wrong here because I didn't. I'm missing a right paren here. Probably got an extra paren there. There we go. So all I did there in that code is replace all the NAs with zeros. Let's keep going. Let's create the traditional batting metrics. All right, so we'll start with teams full, and we'll use our mutate command to create these new variables. So we're going to need plate appearances. Plate appearances is at-bats plus walks plus hit by pitches plus sacrifice flies. Singles equals hits minus X2B minus X3B minus HR. And if I wasn't lazy in this program, I would have renamed X2B and X3B as doubles. Well, I like that we're up 10 at halftime. What is the code in the parentheses? Is it, that's a period X comma 0. Replace underscore NA, left paren, period X comma 0. Right? All right, so we've got singles. We've got bat av. That's what we want. One of the traditional ones we want to calculate. Slug. Right, here's Henry Chadwick's preferred stat from 1869, singles plus 2 times X2B plus 3 times X3B plus 4 times home run, divide by at-bats. OBP we'll look at is hits plus walks plus hit by pitch, divide by plate appearances. ISO we don't use that much, but ISO is just the second part of after the singles, the 2 times doubles plus 3 times triples plus 4 times home run. So it's just bat av minus, it's slug minus bat av. How much extra is created through the extra base hits, and then finally OPS, and this is every mathematician's nightmare, right? On base percentage plus slugging. You're saying, well, why is it every mathematician's nightmare? Well, notice on base percentage, we're dividing by plate appearances. Slugging, we're dividing by at bats, right? And so if we were really adding those together, we should find common denominators and all of that, which we're not doing, right? So don't tell our eighth grade math teachers that we're doing this. All right, so we've got our new variables. We've got our new variables, right? And if we want to open up, teams full and look way out here to the right. Notice they're not there because it only displays columns 1 through 50. And the new variables that we created are out at the end. So that always throws people. So there's our batting average for each team, slugging, on base percentage, ISO, OPS, and so on, right? So there's our teams full, right? And now what we want to do is let's just look at the correlation. We're going to take teams full and we're going to create a new data frame called sum teams full. And sum teams full is just going to be teams full and Control Shift M to give us our pipe operator. And I just want to select runs, bat av, OBP, slug, ISO, and OPS. All right, so some teams full. You just got six variables, just the traditional metrics we want to look at. And what we're going to do with that is we're going to create a correlation matrix. So we're going to plug some teams full into the correlation metrics. We're going to say, yikes, that's a lot of decimals. Let's put a round function around that. So let's round it to 3 decimals. Run again. And here we go. Let's just focus on the top row. Here. Batting average is almost 76% correlated with run scoring. So if we think about correlation, it's a metric from -1 to 1. So, 0.758, that's pretty correlated, right? On base percentage, right? And this is kind of your Moneyball result. Right? On base percentage is even more correlated with runs. Slugging, even more correlated with runs. When we break out the ISO and the bat av are similar correlation, but one's coming from singles and the other's coming from extra base hits. Kind of interesting. Then finally, we see OPS. Boy, 95% correlated with runs. Very, very correlated, right? So let's go back to our slideshow. We can look at these visually, right? The relationship between batting average and runs, yeah, pretty positive. We've got an R-squared of 0.58. We go to ISO a little more, right? But different, right? It's, different pattern, right? OBP, a little tighter pattern to explain run scoring. And then OPS, the tightest pattern, right? So these are all our traditional batting metrics. So let's back up a minute and say, well, let's go back to this, right? So here's what I describe as kind of the Moneyball result, right? Everybody was paying players based on their batting average, and the Billy Bean, was like, well, I can got high on base guys. I can get high on base guys for less money that costs me to get batting average guys. And that's even more correlated with runs, right? So that's kind of cool, right? But boy, in an ideal world, I get the guys that can, get on base and slug, right? The Juan Sotos and some of those guys. So let's move forward from the 1800s and think about, let's get to WOBA, right? Let's get to WOBA. So if we think back to our slugging percentage concept, right? We've got singles, doubles, triples, and home runs. What we really want is the right weights for each one of these, right? How much does a single really score on average? How much does a double really score on average, right? We also are going to need to we're also going to need to throw in a value for walks, because walking is valuable. Maybe the value for hit by pitches. If we went beyond hitting, we'd think about stolen bases and caught stealing, which would be a negative. So let's think about how we would go about do this. And we're not going to do this. We're not going to do this program in R, but you definitely can. Jim Albert and Max Marchi and Brian Baumer, and I'm missing a name, have a book called Analyzing Baseball with R. And they've got a great program that shows you how to take retro sheet data and come up with these linear weights. I'm going to kind of explain it through. Essentially, what we do is find this 24 base out state matrix. And the way to think about the 24 base out states is, look, at the start of every inning, at the start of any inning, teams score about 0.53 runs. Teams on average, you think of it this way, teams on average score about 4.5 runs per game. So that's about 0.5 runs per inning. Once I get a runner on first, so I've got a runner on first and 0 outs, I can expect to Jorge put a nice comment there on how to find data for the book, right? So if I go from nobody on, nobody out to runner on first, I expect to score 0.94 runs instead of 0.53, right? If I go to 1 out, I only expect to score 0.29s through the rest of the inning, right? So essentially what I can do here with these 24 base out states, I can take every batting situation, every time a single happens, right? So let's say a batter has a single, right? We go from 0.53 expected runs in the inning to 0.94 runs. So that difference, that 0.41, that was the value of that single, right? That single was worth 0.41 runs. On the same token, let's say somebody has a single and with the bases loaded. They have a single with the bases loaded. We go from 2.32 runs, 2.32 runs. Let's say we have a single that clears the bases, right? Single that clears the bases, right? So that scored 3 runs plus the new state is 0.94. So 2.32 minus 0.94, the number of runs expected has declined by 3 minus that, or 3 plus that difference, right? So essentially what I can do is take every batting event, whether it's a walk, whether it's a single, whether it's a double, and I can, with this 24 state base out matrix, I can determine the value of every event. What's the average value of a single? What is the average value of a double, right? And that gets us to linear weights. So it turns out that a walk is worth 0.69 runs. These are actually a little higher. We scale them up. We scale them up so that WOBA looks like on base percentage. So the value of a walk is actually a little lower than this. The value of hit by pitch is a little lower than this. So, but basically back to Henry Chadwick's slugging concept, rather than just use blind 1, 2, 3, 4, we now have run values for each event. A walk's worth 0.69, hit by pitch is worth 0.72, and so on. So here's our WOBA equation, right? So, very easy to do in a computer program. In fact, let's go back to our R program and take our teams full, and let's create WOBA. Someone asked what makes hit by pitch more valuable than a walk, and that is a great question. The thing that could make it more worthwhile, I might be walking Mike Trout to get to the next guy, right? But if I hit him, I probably didn't do that on purpose. It was probably a situation where I didn't want to hit him, right? Whereas I can walk right. So that's they're close to the same value, but the hit by pitch is probably less planned. Probably comes in on average worse times, right? So very, very good question, right? So let's look at teams full, and we'll create our WOBA statistics. So WOBA is equal to 0.689 times BB. And what I'm going to do is I'm going to go to my rather than have you listen to me read out all these. I'm just going to cheat a little bit, and I'm going to say WOBA is equal to 0.689 times BB plus 0.72 hit by pitch, and so on, right? So here is our new batting metric WOBA, right? So let's run that, and let's create our summary data frame again. Let's overwrite our sum data frame so that we we'll get runs, bat av, OBP, ISO, OPS, and WOBA. And let's run our correlation again. And let's put our round function around it so that we get. So here's our correlation, batting average 75.8% correlated with runs, OBP 0.867. Notice, OPS really not that much more. WOBA not that much better. OPS is getting us most of the way there, right? So if you got somebody, that you just can't convince that WOBA is the way to go, OPS, they're 99.7 correlated, right? So we look at a lot of these old batting metrics, and yeah, they're still good. Batting average explains something. On base percentage explains a lot. WOBA is, though, the way we really should be going about thinking about how much value a player creates. Let's go back to our slide deck, right? If we think about the numerator, right? If we think about the numerator, and we strip out the little weighting that gets us close to league average on base percentage, and that numerator is essentially a context neutral value of how many runs a player creates. And what do I mean by context neutral? We're looking for context neutral. Context neutral means a single's worth a single's worth a single, right? RBIs are very context specific. Leadoff batters, because they don't come up as much with guys on base, it's harder for them to score RBIs, right? So it's a very context specific statistic, whereas WOBA and the numerator for WOBA, runs created, are context neutral. So essentially I can take my numerator and I can take the actual values of how many runs were created and essentially divide by 10, and that tells me how how many runs above average. I'm sorry, when I divide by 10, it basically tells me how many wins above average a player can contribute or did contribute to the team, right? So this WOBA is a great statistic. It gets us started on run creation. It's a better statistic than any of the old traditional metrics. We're taking this great concept from Henry Chandwick from the 1800s, and we're using computers to get the right weights for each event, right? So we look at WOBA and runs scored, right? So, really high R squared. It does a lot of explanatory power of scoring runs, right? It doesn't, we're not working in stolen bases and caught stealing. We're not working in running first to third. We're not working in anything in terms of clutch hitting, right? Since it's very context neutral. That's why we don't get 100% R squared, but very high R squared, lot of explanatory power for WOBA. Let me some resources for you guys to think about. The SABR Analytics certification program. I've gone through it. I really like it. Fangraphs has really good detailed explanations on all these things that I talked about, especially in terms of WOBA. This book, Analyzing Baseball Data with R, Jorge posted some information there about the GitHub site. I strongly recommend the second edition. If you want to learn to program R, pick up that book and treat it like a cookbook. Go through it page by page. Copy the code. See if you can get it to work the way he gets it to work. I think people call that programming the hard way. That's basically how I did it. I find it very useful. The book's really good for talking about these 24 base out states. A lot of good strategic decisions that can be made. A lot of other, more advanced statistics. And then finally, retro sheet for play-by-play data. There's so many good resources out there, but these are all good. I'm psyched that, Sean Lahman's done a great job, providing us with that baseball reference data. I love that SABR's kind of picking that up too. So what questions do people have? I saw Xavier was ahead at the half. Thanks for posting those. Hannah's question about weighted runs created plus. I think that the plus statistics are real cool because they put them we didn't talk at all about park factors, right? So an R squared of 0.1, not 0.91 here. Some of the difference why it doesn't explain all of run scoring is certainly park factors. I also like the weighted the plus statistics because they put everything on a scale. Anything above 100, I know, is above league average. Anything below is below. So, weighted runs created plus is a great stat. Kind of you think about that numerator of WOBA, that's one of the early steps in getting to weighted runs created plus. So, definitely a good stat. Matthew says, what other application I use with run RE24? The cool thing about the RE24, and the book goes through it in such precision. But like, for instance, with the RE24, we could say, look, I've got a runner on first. I expect to score 0.94 runs through the end of the inning, right? What if I bunt him over? Okay, I go from 0.94 to 0.72, right? Well, if that's what happens, I go from a runner on first and no outs to a runner on second and 1 out. I actually expect to score less runs in the inning, statistically. So there's just a great all kinds of great strategy applications with the RE24. I think it's a great place to start. I mean, go through that book and understand the details of RE24 because there's so much stuff you can do it. You know, it's the beginning part of linear weights and way to run created, so on. Mia says, what projects do you recommend to show our school's baseball teams? You know, here's one that I do. I'm going to see if I can pull it up. One of the things, you know, a lot of teams does is advanced scouting, right? And we play Tulane tomorrow night. So let's see if I can bring this up. So this is what we put together for tomorrow night, right? And basically I just took you know, 643 data, and this is a template the coach likes, where he's got data broken out left versus right. And basically we're taking the, you know, this, and you can do this with, we do this with, you can do this with baseball reference data. They have college data, right? You populate a spreadsheet with all the, you know, this flat file, and use your lookup commands to populate a template the way the coach likes it, and then pays special. So he sits down to do scouting, and he's got all the numbers. He doesn't have to worry about fat fingering in any of the numbers because you've created this nice template. He just has to fill in these boxes like, hey, let's throw this guy. This guy will swing it in anything. You know, just, you know, don't put anything down the middle of the plate, right? Or so on. So I think that's a great question in terms of projects. Can you help them out with their advanced scouting? What can you do? I think if you're thinking about helping a team, what can you do to free up the coach's time so they can work with players? What you can do to free up the coach's time so they can spend more time watching video to populate their charts. So I think a project like this where you're using raw data and you're putting it in a really nice presentation form. So all they have to do is go in and put their plan of attack in, or something that's going to save them time, right? So that, I think that's a great question. But I think you want to think about, I think what baseball coaches worry about is, and a lot of my expat students, they end up taking up more of my time than they contribute back to the program, right? And so then it gets, you know, and that's always hard, right? Can you help tag the TrackMan data, right? You know, try really hard, you know, stuff like that. So, Mark, what do I think is the most underutilized statistic in baseball? There's some cool stuff that people are starting to do with pitch data, where they look at the value of pitches. I'm not explaining it. John Kalk, Kalk, John Kalk. He was with the Twins organization last I heard. He has this Kalk ERA that you actually apply for each of a pitcher's pitches, and I think that's very interesting. You say, well, this pitch is better than this from an ERA perspective, so I should throw this one more and this one less. So that was good. Tyler, is someone who's new to where would I recommend that you get going? I'd pick up that Analyzing Baseball Data book with R and the book, and those two I think are great places to start. Isaac, if you're predicting runs or RBIs per player, I think that the thing with WOBA, since it's context neutral, right? I mean, it's gonna understate how many RBIs a leadoff hitter gets, and it's gonna overstate how many. It's going to understate how many runs they score and overstate how many RBIs they get. So where they are in the lineup is going to matter. So it would be interesting to do some of those. That would be maybe an interesting project. You know, how biased is WOBA or the numerator of WOBA based on where you bat in the order. I think that'd be a cool project. It's a good idea. I mean, Paul Pavitt says, how would you recommend going about trying to get WOBA factors for college baseball? And I mean, you, that's, and I think one of the things you should take away from this is like, if you don't have WOBA and you're trying to evaluate, I mean, OPS is really almost as good. So why spend all this time, trying to come up with a fancy WOBA when you've got an OPS that has 99 correlation. So, and I did mean Josh Cock. Thank you. Thanks for throwing that in, Josh and Jacob. Oh yeah, so you want to see the numerator on WOBA is at bats plus BB plus sacrifice flies plus hit by pitch. Great questions, guys. I'm guessing that Xavier might not be up as much since I haven't seen a post in a while. I'm gonna run down and find out. Fantastic questions. Enjoyed the session. Thank you.
Dave, great job. Thank you so much. You filled an hour and 10 minutes admirably.
Thank you. Thank you. It was fun. I could have gone another hour.